Today I'm going to show you my work. This is called the proximity sensor tester. This one comes in two units. One is the battery charger and the other one is the battery pack with the proximity sensor circuit tester on it. So let's go first here in the software side. It's not here. Okay. So these are the codes. I will scroll you down through all the codes here. By the way, my coding documentation is minimal. Okay, that's it. So let's go to the top. So here is the declaration of my variables. This is the data pin, which will go into the DS pin of the 748C595 shift register. By the way, I'm using an Arduino chip, 748C595 shift register, and a 7-segment display. So it will normally display the charge voltage on the battery, and it will display finish when the charging is done. So let's move on. This is the data pin. This is SCP pin, or the shift clock register. SCP is the storage clock register. This is the variables. This one is my driver to the 7-segment display for the 10th digit, the 1st digit, and the decimal digit. The PWM output of the battery charger. Here, these are the variable again, the 10th digit, 1st digit, and the decimal digit. So this is an array which will give display to the 7-segment display. This is 0, 1, 2, 3, 4, 5 until 9. So these are the digit of the that will be displayed on the 7-segment display. This is the decimal digit, and this is the 1st digit. 1st digit. So you notice the 1st digit is different from the decimal digit. 253, 252, 97, 96, 219, 218, because this one includes the decimal point. And here I have okay, this is the 10th digit. See, normally I'm using here byte, but my variables here are integer, but it's still working fine. Pin mode, the functions, there are the functions. This is the functions for my LED 0 display. So this one here, I'm using the shift out. 0. So number 0 should be selected, or array 0 should be selected, array element 0 should be selected, and here you select it is referencing to one element of the array, and here the second element of the array. So it will display all 0. Okay, let's move on. Okay, let's go to the main loop. Okay, this is the main loop. So it reads the variable of the analog input and it's stored in the sensor val. So sensor val, this is the 10-bit analog to digital converter, and this will be converted into 0 to 5 volts. And then here, from 0 to 5 volts, 5 minus the sensor value, so it will give you the difference between 5, the difference of the it will give the difference of 5. So and then divided by 5 by 24, it will convert. So this will convert from 24 to 0. This is in reverse calibration. Instead of 0 to 24, it will give you 24 to 0. So here, if sensor val is less than or equal to 5, the output should be 0. So it means, and the display also is 0. So it means when you just plug in, we just switch on the power, the battery pack. If the value is 0, the value should be 0 because there's no battery attached yet. So the analog reading it as 0, so the output should be 0 and it should display 0. And here, if the sensor value is less than or equal to 16, it means it is it's starting from 5 because here it's start from less than or equal to 5. It means it started from 0 to 5. Here it started from 5. This would be above 5. So maybe 5.1 to 16. Your value should be, the analog value of this will become to 5 or maximum value, maximum output of the PWM, and it will display the LED value. The LED value, it means the actual value, the actual charge on the battery. So we will see it later on. And if the value is less than or equal to 17, so it means equal to 16.1 and above, up to 17, my PWM output becomes 150, and still LED value. LED value is the actual value, actual reading of the sensor. And here, if the value is less than or equal to 18, the PWM output becomes 75, and still LED value. And here, if the sensor value is equal to less than or equal to 18.5, so it will display finish, or the maximum charge that the battery can handle is reached already. I made it 18.5, and the analog output will become 0. Till 19.5, it will display LED finish and PWM output should be 0. And here, if the sensor value is less than or equal to 20, it will give an output 0 and display 0. Till LED value is less than or equal to 24. it will output 0, and the LED value or the 7 segment value, this is not the LED LED, this is 7 segment value, it becomes 0. So that's it. So let's try now. In my circuit here. So this is it. This is the Arduino chip in it. So just never mind the wirings here. So we will simulate that one using the potentiometer. So we will simulate to. So we'll make it 0. So that is 0. When I start to move the potentiometer, it will give the value like, see, so it gives a value of 5. So see, before 5, from 0 to 5, it will give a 0 value. So when it just at 5, so it will start displaying the LED value or the 7 segments value now, till they will increase now the value. So let's go. But by the way, this is a bug. I cannot fix it. So 11 volts. This is the charge of the battery. Imagine that this is the charge of the battery. 15.5, 16, 17. So within this value from 5.1 to 16, this is a full PWM output. 15, 16, 17. So I have the LED here. Where's the LED? I see the LED. You will see the changes of the LED when see. So that is 0. That is 0 PWM. There's no output in it. See the LED. Now it will give an output when it becomes 5, more than 5. See, 5. That is full PWM. Now let's move on till we get 16, and then you will see it will reduce the intensity of that LED. 15, 16, 16. See, $16. So 17, the PWM output is reduced, and when it reaches 18.5, it will display fin, that is fin or finish. So it will keep on strobing. When it is already full, it will keep on strobing from finish to 17, something like that. So when it's also above this one, it will become 0. It will display 0. So that's it. Okay. Thank you.